Hello learners, welcome to the Tutor channel. In this video, we will learn mastering Oracle SQL from O'Reilly book, chapter 1. In this introductory chapter, we explore the origin and utility of the SQL language, demonstrate some of the more useful features of the language, and define a simple database design from which most examples in the book are derived. What is SQL? SQL, which stands for Structured Query Language, is a purpose language used to define, access, and manipulate data. SQL is non-procedural, meaning that it describes the necessary component and desired result without dictating exactly how results should be computed. Every SQL implementation sits atop a database engine whose job is to interpret SQL statements and determine how the various data structures in the database should be accessed in order to accurately and efficiently produce the desired outcome. The SQL language includes two distinct sets of commands. Data definition language, or DDL, is the subset of SQL used to define and modify various data structures, while data manipulation language is the subset SQL used to and manipulate data contained within the data structure previously defined via DDL. DDL includes numerous commands for handling such tasks as creating tables, index, views, and constraints, while DML is comprised of just four statements: insert, update, delete, select. Some feel that DDL is the sole property of database administrators, while database developers are responsible for writing DML statements. But the two are not so easily separated. It is difficult to efficiently access and manipulate data without an understanding of what data structures are available and how they are related. Likewise, it is difficult to design appropriate data structures without knowledge of how the data will be accessed. That being said, this book deals almost exclusively with DML except where DDL is presented in order to set the stage for one or more DML examples. The reason for focusing on just the DML portion of SQL include DDL is as well presented in various books on database design and administration as well as in SQL references guides. Most database performance issues are the result of inefficient DML statement. Even with partly for statements, DML is a rich enough topic to warrant not just one book, but a whole series of books. So, why should you care about SQL? In this age of internet computing and entire architecture, does any even care about data access anymore? Actually, efficient storage and retrieval of information is more important than ever. Many companies now our services via the internet. During peak hours, the services may need to handle thousands of concurrent requests, and unacceptable response times equate to lost revenue. For such system, every SQL statement must be carefully crafted to ensure acceptable performance as data volumes increase. We can store a lot of we can st- we can store a lot more data today than we could 5 years ago. A single disk array can hold tens of terabytes of data, and the ability to store hundreds of terabytes is just around the corner. So, software used to load or analyze data in this environment must harness the full power of SQL in order to process every increasing data volumes within constant or shrinking time windows. Hopefully, you now have an appreciation for what SQL is and why it is important. The next section will explore the origins of the SQL language and the support of the SQL standard in Oracle's products. A brief history of SQL. In the early 1970s, an IBM research fellow named Dr. E. F. Caught an effort to apply the rigor of mathematics to the then untamed world of data storage and retrieval. Code's work led to the definition of the relation data model and language called DSL or Alpha for manipulating data in relational database. IBM liked what they saw, so they commissioned a project called System or R to build prototype based on Code's work. Among other things, the System or R team developed a simplified version of DSL called Square, which was later renamed SQL and finally renamed SQL. The work done on System R eventually led to the release of various IBM products based on the relational model. Other companies such as Oracle rallied around the relational flag as well. By the mid-1980s, SQL had gathered sufficient momentum in the marketplace to warrant oversight by the American National Standard Institute or ANSI. ANSI released its first SQL standard in 1986, followed by update in 1989, 1992, and 1999. 30 years after the System or our team began prototyping a relational database, SQL is still going strong. While there have been numerous attempts to dethrone relational database in the marketplace, well-designed relational database coupled with well-written SQL statements continue to succeed in handling large, complex datasets where other methods fail. Oracle SQL implementation. Given that Oracle was an early adopter of the relational model and SQL, one might think that they would have put a great deal of effort into conforming with the various ANSI standards. For many years, however, the folks at Oracle seemed content that their implementation of SQL was functionally equivalent to the ANSI standards without being overly concerned with true compliance. beginning with the release of Oracle XDI. However, Oracle has stepped up its efforts to conform to ANSI standards and has tackled such features as the case statement and left-right full author join syntax. Ironically, the business community seems to be moving in the opposite direction. A few years ago, people were much more concerned with probability and would limit their develops to ANSI-compliant SQL so that they could implement the system on various database engines. Today, companies tend to pick a database engine to use across the enterprise and allow their developers to use the full range of available options without concern for ANSI complaints. One reason of this change in attitude is the advent of an entire architecture where all database access can be contained with a single tier instead of being scattered throughout an application. Another possible reason might be the emergence of clear leaders in the DBMS market over the last 5 years, such as that managers perceive less risk in which database engine they choose. Theoretical versus practical terminology. If you were pursue the various writing on the relational model, you will come across terminology that you will not find used in this book, such as relation and tuples. Instead, we use practical terms such as tables and rows, and we refer to the various parts of an SQL statement by name rather than by function. In example, select clause instead of projection. With all due respect to Dr. Cott, you will never hear the word tuple used in business setting. And since this book is targeted toward people who use Oracle products to solve business problems, you won't find it here either. A simple database. Because this is a practical book, it contains numerous examples. Rather than fabricating different sets of tables and columns for every chapter or section in the book, we have decided to draw from single, simple schema for most example. The subject area that we choose to model is parts distributor, such as auto parts, wholesaler, or medical device distributor, in which business files, customer order, or one or more parts that are supplied by external supplier. If you are unfamiliar with entity relationship models, here is a brief description of how they work. Each box in the model represents an entity which correlates to a database table. The lines between the entities represent the relationship between tables which correlate to foreign keys. For example, the customer order table holds a foreign key to the employee table, which signifies the salesperson responsible for a particular order. Basically, this means that the customer order table contains a column holding employee ID number, and that for any given order, the employee ID number indicates the employee who sold the order. If you find this confusing, simply use the diagram and illustration of the table and column found within our database. So wait, and you should find that the relationship start making sense. DML statement. In this section, we introduce the four statements that comprise the DML portion of SQL. The information presented in this section should be enough to allow you to start writing DML statements, as is discussed at the end of the section. However, DML can look deceptively simple, so keep in mind while reading the section that there are many more facets to DML than are discussed here. The select statement. The select statement is used to retrieve data from a database. The set of data retrieved via a select statement is referred to a result set. Like a table, a result set is comprised of a row and columns, making possible to populate the table using the result set of a select statement. The select statement can be summarized as follows. Select from and where. While select and from clauses are required, the where clause is optional, although you will seldom see it omitted. We therefore begin with a simple example that retrieves 3 columns from every row of the customer table. Since we neglected to impose any condition via a where clause, our query returns every row from the customer table. If we want to restrict the set of data returned by the query, we could include a where clause with a single condition. Our result says now includes only those customers residing in the region with a region ID of 8, but what if we want to specify a region by name instead of region ID? We could query the region table for a particular name and then query the customer table using the retrieve region ID. Instead of issuing 2 different queries, however, we could produce the same outcome using a single query by introducing as join. Our from clause now contains 2 tables instead of 1, and the where clause contains a join condition that specifies that the customer and regions table are to be joined using the region ID column found in the table. Joins and join condition will be explored in detail in chapter 3. Since both the customer and region table contain a column called name, you must specify which table's name column you are interested in. This is done in the previous example by using dot notation to append the table name in front of its column name. If you would rather not type the full table name, you can assign table aliases to each table in the from clause, and Use those aliases instead of the table names in the select and where clause. In this example, we assign the alias C to the customer table and the alias R to the region table. Thus, we can use C and R instead of customer and region in the select and where clauses. Silly clause state elements. In the example thus far, the result sets generated by our queries have containing columns from one or more tables, while most elements in your select classes will typically be simple column references. A select clause may also include While the first three items in this list are fairly straightforward, the last item merits further discussion. Oracle makes available several phantom columns known as pseudo columns that don't exist in any table. Rather, they are values visible during query execution that can be helpful in certain situations. For example, the pseudo column row ID represents the physical location of a row. This information represents the fastest possible access mechanism. It can be useful if you plan to delete or update a row retrieved via a query. However, you should never store row ID values in the database, nor should you reference them outside of the transaction in which they are retrieved, since a row ID can change in certain situations, and row IDs can be reused after a row has been deleted. Interestingly, your select clause is not required to reference column from any of the table in the from clause. For example, the next query's result set is composed entirely of literals. Since there are 30 rows in the customer table, the query's result set includes 30 identical rows of data. Ordering your result. In general, there is no guarantee that the result set generated by your query will be in any particular order. If you want your result to be sorted by one or more columns, you can add an order by clauses after the where clause. The following example sorts the result from our New England query by customer name. You may also designate the sort columns by their position in the select clause to sort previous query by customer number, which is the first column in the select clause. You could issue the following statement. Specifying sort case by position will certainly save you some typing, but it can be often lead to errors if you later change the order of the column in your select clause. Removing duplicates. In some cases, your result set may contain duplicate data. For example, if you are compiling a list of parts that were included in the last month order. The same part number would appear multiplied times if more than one order included that part. If you want duplicates removed from your result set, you can include the distinct keyword in your select clause. This query returns the distinct set of parts ordered during July of 201 without the distinct keyword. The result set would contain one row for every line item of every order, and the sum part would appear multiplied times if it was included in multiple orders. When deciding whether to include distinct in your select clause, keep in mind that finding and removing duplicates necessitates a sort operation, which can add quite a bit of overhead to your query. The insert statement. The insert statement is the mechanism for loading data in your database. Data can be inserted into only one table at a time, although the data being loaded into the table can be pulled from one or more additional tables. When inserting data into a table, you do not need to provide values for every column in the table. However, you need to be aware of the columns that require no-null values and the ones that do not. The not-null designation for the map employee ID, LNAME, and department ID columns indicates that values are required for these three columns. Therefore, we must be sure to provide values for at least three columns in our insert statement, as demonstrated by following. So sometimes the data to be inserted needs to be retrieved from one or more tables. Since the select statements generate a result set consisting of rows and columns of data, you can feed the result set from a select statement directly into an insert statement. In this example, the purpose of the select statement is to retrieve the department ID for the accounting department. The other columns in the select clause are supplied as literals. The delete statement. The delete statement facilitates the removal of data from the database. Like the select statement, the delete statement contains a where clause that specifies the condition used to identify a row to be deleted. If you neglect to add a where clause to your delete statement, all rows will be deleted from the target table. The following statement will delete all employees with the last name of Hooper from employee table. In some cases, the value needed for one or more of the condition in your where clauses exist in another table. For example, your company may decide to outsource its accounting functions, thereby necessitating the removal of all accounting personnel from the employee table. The use of the select statement in this example is known as subquery and will be studied in detail in chapter 5. The update statement. Modifications to existing data are handled by the update statement, like the delete statement. The update statement includes a where clause in order to specify which row should be targeted. The following example shows how you might give a 10% raise to everyone making less than $40,000. If you want to modify more than one column in the table, you have to choose provide a set column or value pairs separate by columns, or provide a set of columns and a subquery. The following two update statements modify the inactive DD and inactive IND columns in the customer table for any customer who hasn't placed an order in the past year. The subquery in the second example is a bit forced, since it uses a query against the dual table to build a result set containing two literals, but it should give you an idea of how you would use a subquery in an update statement. In later chapters, you will see far more interesting use for subqueries. So, why are there 13 more chapters? After reading this chapter, you might think that SQL looks pretty simple, at least the DML portion. At a high level, it is very simple, and you know enough about the language to go write some code. However, you will learn over time that there are numerous ways to arrive at the same endpoint, and some are more efficient and elegant than others. The true test of SQL mastery is when you no longer have the desire to return to what you were working on the previous year. Rip out all the SQL and code it. For one of us, it took about 9 years to reach that point. Hopefully this book will help you to reach that point in far less time. While you're reading the rest of the book, you might notice that the majority of examples use select statement with the reminders somewhat evenly distributed across insert, update, and delete statement. This disparity is not indicative of the relative importance of select statement over the other 3 DML statements. Rather, select statements are favored because we can show the query's result sets, which should help you to better understand the query, and because many of the points being made using select statement can be applied to update and delete statement as well. So Please subscribe this channel and like and share and comment this channel. See you on next chapter. Thank you and bye bye.